Welcome to the third and final video in this series, where I'm marking step solutions submitted by our viewers. This final solution, I feel, strikes a fantastic balance in that there's a nice amount of clarity, everything is explained very clearly, steps are justified, but at the same time there's a nice use of abbreviations and notation rather than full sentences in order to keep things compact and save time. If your work hasn't featured in this series, I'll be in touch in the coming days with your marked script and some feedback for you. So this is a really interesting question. We consider a family of differential equations, by which I mean for each choice of positive integer k, the differential equation star is really a different differential equation. And we define for each value of k, yk to be the solution of that differential equation passing through the point 1, 1. Crucially, in the preamble to the question, they tell us that we can assume that there is only one such solution for each value of k. So that means that in what follows, we don't need to, for example, solve the differential equations from scratch. If I want to demonstrate that y of a given k takes a particular value, all I need to do is verify that it meets the required conditions. That is, it solves the differential equation and it passes through the given point. So here the student seems to have very clearly understood this overarching idea in the problem. So in part 1, we just need to verify that y1 truly is x. So the student has nicely recognized that we need to do two things. We need to verify the boundary condition, and we also need to verify that the differential equation is obeyed. So let's see, how do we begin? They state the exact differential equation in the case k equals 1. So that's reasonable. That means we know which differential equation we're looking for. They state what we're setting, and they verify that y1 is equal to 1. So that gets what is on the mark scheme, the second B mark, the second independent mark, because they actually do the differential equation first. Now, unfortunately, because y1 is literally just x, there's no non-trivial algebra we can show in plugging x equals 1 in that shows we're not just bluffing. But the fact they've used the word verify, the fact they've said satisfied, shows that they're clearly actually plugging it in and seeing that this is the case. They're not just saying they'd like it to be true. So there's no doubt whatsoever that mark is clearly received. And then I really like the comment here as well. So they're telling the reader what they're doing. Substitute into the differential equation, having computed this. So I, as the marker, know exactly what they're doing at that point. And moreover, when I'm looking for where I need to go on the page to find where I can award, the marks for substituting in, I know exactly where to look. So the likelihood of an unfavorable marking error is very low. They've clearly plugged in correctly. They've computed the derivative. They've put it in. So this is completely fine. The one thing that I might have liked there is to write LHS equals, just to make it clearer that what you're really doing ideally is plugging the claimed solution into one side of the differential equation and then verifying that what you get out is the other side. So we could have then written equals RHS there. There's no danger of a lost mark here, but you don't want to give the examiner the impression that you're assuming that the differential equation holds and plugging the solution into both sides at once, assuming equality. You're plugging it into one side and seeing that it gives a match. So this is really nice presentation. Slightly more minor point, I like how we've got this spacing out of empty lines in between the written work. It might mean you use a few more sheets of paper in the exam, but it makes it so much easier to disentangle what's going on. So far, perfect solution. Now, in part 2, it's a very similar game, but now we've got a slightly more complicated function to verify in the case of k equals 2. In terms of the verification, so this is really good. They've told me what they're doing. They're verifying the boundary condition. I like that they've left the numbers unprocessed here. Writing 2 minus 1 rather than just 1 straight away makes it clearer that they're actually verifying by plugging in and they're not just, for example, bluffing. So the B mark for part 2 is definitely received there. And then there's an M mark and an associated A mark for plugging in. So clearly they've computed the derivative correctly Again, they've told me that they're substituting it into the differential equation, and they've done so correctly. So they've said what the dE is, and they've obviously just subbed in for dy by dx and also for y squared. So there, they've just expanded the brackets. So this is absolutely fine. Definitely both of those marks are received. The only thing, again, that I might have liked if I'm being picky is saying LHS equals RHS equals, just to avoid any doubt whatsoever that they're falling into the trap of assuming the equation holds. But it's clear enough that what they're doing is looking at the left-hand side and processing, so there's no danger of a lost mark here. Okay, moving on to part 3. So it's the same basic idea, but now things are becoming slightly more complicated because, for example, we're obviously going to need to use the chain rule to differentiate this function z. What I really like is that the student has collected together here some key results that they're likely to use later. The function z is defined in terms of yn, and therefore it stands to reason that in the analysis that follows, we're going to have to appeal to the properties of yn in order to make progress. Having noted that, by numbering the equations, it's now very easy for them to refer back and say, for example, by equation 1, by equation 2. And in this way, there's no doubt whatsoever how and where the given properties are being applied. So let's see. In terms of the marks allocated, the first M and A mark is for computing dz by dx. This is clearly done completely correctly here, so we definitely get those marks. Then the next 2 M marks and also 2 A marks come from actually plugging into the differential equation, and for the final A mark, appealing to the fact that yn obeys what the student here has called equation 2. So let's see, they've set this up, they've computed the square, they've computed that term, and they've put it in. I again might have liked to see LHS equals, just so I know without any doubt what's being done, but no real jeopardy here. So let's see, they've plugged in what they had, they've factored some things out, they've told me that they're using equation 2, so that's exactly what that second A mark is all about. And then they've cancelled terms and processed it to the right expression. So this is absolutely fine, and they're definitely going to receive the M mark, the A mark, or sorry, 2 M marks rather, and 2 A marks, having verified the differential equation. So again, we could say equals LHS equals RHS, but it's no issue. Okay, has the student remembered to also verify the boundary condition for the last 2 marks? Well, if we turn to the next page, we see yes, they have. So they've plugged 1 in, and they've used that yn1 is 1. The only thing that I would have liked to see is they could have written by equation 1 here, because in going from there to there, the student is using the property that yn obeys this by definition. So having numbered the equation, it seems a shame not to spell out where it's being used, but nonetheless, it's obvious enough. There's no danger of a lost mark here. And it's very helpful also to include this final sort of concluding remark, summarizing the argument. When you've been proving something by doing a long, arduous calculation, it's very helpful to include a kind of summary argument at the other end, just bringing it all together. Although it's not the case here, sometimes there will be marks specifically allocated, often E marks, for these sorts of concluding remarks. So this is really important. Okay, so far not a single mark dropped. Now we come to part 4. So in part 4, well, it's the most challenging part of all, because we consider as a candidate for ymn, which we're going to call v, we consider one of the y's plugged into another y. So this is obviously going to require some sneaky chain rule. Let's see what happens. So the first B mark comes from computing dv dx. So they've done this correctly. I'm perfectly happy with what's happened here. They've also, of course, collected some results there for use later, just like before. That's really helpful. My one slight gripe here is I don't really like that notation. So the reason I don't like that notation is because given that I'm feeding yn prime something other than x, there is a slight question mark as to whether that means take the function yn, differentiate it with respect to x, and then evaluate that at ym, or does it actually mean that you differentiate with respect to what the argument is, which is actually ym? Now, this is something that you could define and compute perfectly reasonably via the chain rule, and when you use the prime notation in a context where the argument is not x, there's always a slight risk of ambiguity, either on the part of the reader or even on your part when you're going back through your workings. Now, the correct interpretation is the former, and so given that that is strictly speaking what the written notation means and it's what it's supposed to be, I don't think there's any danger here of losing that mark. However, I think it would have been better to write out those derivatives explicitly. So then we're plugging into the differential equation. So just like before, the student's doing a really nice job of breaking it down into separate pieces and computing all the various components. So, for example, here, well, we've taken already what v prime squared is, and then we're considering 1 minus x squared v prime squared, having subbed that in because it is something that will feature later. It would have been nice to say here what's being done. So here we're replacing 1 minus x squared d by dx ym squared with this, and we're actually doing that, if you think about it, by using, well, the original equation for ym, right? So the original differential equation, what the question calls star, is actually being applied here. Given that that's quite an important step, it would have been nice to say that. So by star with m equals k. There won't be a lost mark here. It's sufficiently clear, but if things went wrong, it's going to put us in a bit more jeopardy. So certainly that means that we've managed to get, I think that really covers pretty much the first 3 m marks. The only slight difference is that in the mark scheme, they're processing both terms at once, whereas the student here is just doing the first term. However, they do write there m squared, n squared, v squared, and they do then process that to what it is. So I'm seeing everything I need to award the first 3 m marks. And then subsequently, what have they done? They've collected things together, and they've then used the differential equation for ym, but evaluated, or the differential equation for yn, should I say, but evaluated at x equals ym. Now, that's fine, that's allowed, because the differential equation is meant to be true for all x, so I can substitute x for whatever I like, even another function. So clearly, that is precisely what that final m mark is all about. That's been nicely spelled out, and therefore we have managed to establish the differential equation because we get m squared n squared. So we get that a mark. And then has the student explicitly on the page verified the boundary conditions? So where have we got y1? So that's actually happened, sorry, up here. So they've done v1 equals this. They've used that that's 1, and therefore they've got 1 out. So that a mark for the boundary condition is also received. Again, it might have been nice to write something like by the definition of ym, just to state where that's coming from. So a couple of very, very small bits here where slight explanatory remarks could have helped, but by and large, this is close to perfect work. When there are big steps being made, there are nice comments either justifying what's being done or even just helping to signpost to the reader where to look for different steps. However, despite this fantastic clarity, the comments are brief and concise. There's not long paragraphs all over the page. There are brief remarks in a few words, just cutting to the heart of the key point. So not only does this comfortably receive 20 out of 20, but I also expect that this work could reasonably have been completed in well under the 30-minute allowance. All of the work we've covered in this series has been of a really high quality. Of course, it's important to remember that presentation is more challenging on some questions than others. If a question is very logically subtle, especially if you're yourself confused about where the maths is actually going, it can be more difficult to bring the reader along with you. Many students fall into the trap of writing less and less the more confused they become. This makes sense. If you don't feel certain about your ideas, you're going to feel less inclined to make an effort to communicate them clearly. But a good rule of thumb is to do precisely the opposite. The less certain you are of where things are going, the more care you should take to put all your steps in context and make it clear to the reader what you're actually trying to achieve. Because at least if the reader knows what you're trying to do, it's easier to dig out the opportunities to award you method marks. Believe it or not, the examiners really are on your side and they're looking for opportunities to award marks, not to deduct them. At this time of year, it's important to be doing lots of mocks, not only so that you can perfect your presentation, but also so that you can learn all the many tricks and ideas which feature prominently in STEP questions. I'll be taking a mock myself. In our next video, I'll be completing STEP 2025, Unseen. And if you'd like to see how that unfolds, do remember to subscribe. Thanks as ever for watching.